Yesterday we dusted off the cobwebs of exponent laws, okay, and there were a handful that you need to know and memorize, okay, because we're not just doing simple exponent laws, right? You guys are to the point where we're going to do more complex questions for you to do. So just a reminder, okay, when you have, for example, x squared y to the negative 3, okay, x squared y to the 1, okay, when you have the same base and you're multiplying, so this, we're just basically multiplying the x's and adding the exponents, okay. We were reminded that all of our answers need to have positive exponents. Okay, so in order to change things to positive exponents, okay, if it's negative, it's got to flip sides. It's got to flip over the bar. If there isn't a bar, you draw a bar in, okay, so that your answer, okay, has a positive exponent. If we were to have, for example, if they asked us to simplify and we had x squared with a y, say the negative exponent was on the bottom. Okay, we still have to write this with a positive exponent, so just the y would flip up to the top. Okay, so it would be x squared y cubed. Okay, so remember, only flip the one where the exponent is attached to. Let's say that we had 3x to the negative 2. Okay, this one, only the x has the negative exponent, so only the x would move. Okay, the 3 would stay where it is because it doesn't have a negative exponent.
So you don't move whatever's attached to it, just the x and the exponent.
Yeah. Okay. Yeah. So like let's say we had a coefficient. Okay, so only the x in this case would move, even though there's still a multiplied by 3 and a multiplied by y. Okay. Okay, so we reviewed our exponent laws. Okay, the next thing that we did is we learned something new. We went straight into exponential equations. So remember that an equation, okay guys, I feel like I'm talking over you. Okay, like give me a chance, okay, to get through the lesson, and then I will give you a chance to work on your stuff and have a conversation with your neighbor. Okay, now is just not the time, even for you guys. Okay, so we talked about an equation. As soon as we have an equal sign, so for example, we have 5x to the 1/2 is equal to 45. We went with a question similar to this yesterday. When we have an equal sign, okay, this means that we are solving for x. This is different, okay guys, this is different from this. This question did not have an equal sign in it, and we're just simplifying. Okay, this question has an equal sign, which means we're actually solving for x. And so we have 2 steps to this type of problem. The first step is we needed to isolate the x part. So if there's a number in front, like this, we have to divide both sides by 5. Right, because we want the x all by itself. Okay, and then the second part, step 2, actually we'll do blue. Step 2 was then we're trying to get to x with the exponent 1. Right, because then that means we're just solving for x. Well, right now it has an exponent of 1/2. It has an exponent of 1/2. And we saw yesterday that if we were to raise both sides, because what you do to one side, you have to do to the other, right? I divided by 5 on one side, I had to divide by 5 on the other. If I put this to an exponent, okay, if you do the reciprocal, anything multiplied by its reciprocal, its answer is 1. Okay, so that's why we chose to do the whole thing and raise it to the exponent of the reciprocal, okay? Because it's an exponent. So I can't say we're multiplying. We're not multiplying by 2 over 1. We're raising both sides to the exponent 2 over 1. Yes. Okay, so 2 over 1 is the exact same as 2, so we're just basically squaring both sides. Okay, so when we do that, we end up with, okay, x to the power of 1, and this one was, okay, 9 squared is 81. Okay, so in this case, our answer is 81. Okay, what would happen if I gave you a question that looked like this? That is a 2. Okay, what if, okay, in this case, there's something hanging on to the x. I need to isolate for my x, but I've got to divide by 4 hanging on. Yeah, I'm going to multiply by 4. I'm going to multiply both sides by 4 to get x by itself. Okay, so don't forget, you're just undoing whatever operation there is. So if they throw one at you that you haven't seen before, because it's divide, just know that you multiply. So now we have x to the 2/3 is equal to 8. Okay, and then I'm going to raise both sides by the reciprocal of the exponent. And I didn't pick nice numbers for it to turn out into a nice thing. Okay, but x is going to be whatever, when you put that into your calculator, whatever that number is. Okay. Actually, yeah, I'll do a better example because that one will be a decimal. All right, so today we're going to kind of pick up, so turn your page to page 2. Okay, on the bottom of the page, I didn't want to introduce a brand new topic at the end of class. I kind of figured you guys were like full with new knowledge. Okay, so we're going to pick up right here. So what we're going to do is we're going to talk about changing numbers into, like, we're going to write an equivalent number, but with a special, like with a base. So what I'm talking about is, hey, guys, I don't want you to miss this. It's not difficult, but if you're not paying attention, when it comes to your turn, you're going to say, I don't know what to do, because you weren't paying attention. Okay? If I were to ask you to write 9 with a base 3, that means that I want you to come up with, you're going to change the base. Remember, the base is just the big number on the bottom. And you need to think of what exponent you could use so that 3 to some exponent is the same as 9. Okay, 3 squared is 9. Okay, so some of these you're going to just like get just like that. Okay, if I said 16, okay, with the base 4, what exponent is it going to have? 2. Okay, guys, how about 64? Can you change 64 to something with, okay, base 4?
I think it's 4.
Okay, so if you're not sure, this is where you pull out your calculator and you check. Okay, yeah, what did you get? 3. Okay, and how did you get that? You went to your calculator and maybe you did like 4 squared. No, that's 16. 4 to the power of 3. Oh, that's 64. Maybe you thought, maybe it's 4, right? 4 to the power of 4. Oh, that's too big, right? So some of this, right, when they tell you the base, you can just do a little bit of, like, if you don't know it, you can do guess and check, right, until you narrow it down. Some of them, like if I gave you 125 and I asked you to change that to base 5, what would the exponent be? Okay, it is 3. Okay, you gave me all of them. You were working your way down until I gave you the nod. Okay, So that's what we're doing here, okay, on these questions. So what we're going to do is we're going to convert each to a different base, and then we're going to apply our exponent laws. Okay, so it says change the 9 to a base 3. So that means the 9 part becomes 3 squared. Now, guys, there's already something there. So what happens is what's there just gets multiplied by the new exponent that you just put there. Okay, so this is the 9 part, and the 2x was already there. Okay? So now it's just going to be 3, and you're just going to, remember, power of a power, we multiply these. So it's just going to be 4x. Okay, so 125, change that to a base 5. So we just did an example where we saw that it was 5 to the exponent 3. And then there's still this 2 minus x on the outside. Okay? If I look over at your notes, are you going to be caught up to where I am? No, not yet. Okay, we're not even on the right page. Okay, yeah, we're there. Okay, so now what you do when you do power of a power, you're going to multiply, which means that you're going to distribute through the brackets. So you should end up with 5 to the exponent 6 minus 3x. Okay, so make sure that when you write your exponent that it's like up and a little bit smaller. I don't want it to look like 5 times 6 minus 3x. Okay, the 6 minus 3x is the exponent, which is raised up and a little bit smaller, just like how I have it. Okay, in the next question, it wants you to change the 2 and the 16 to base 2. Okay, sorry, the 8, did I say the 2? It wants you to change the 8 and the 16 to base 2. Okay, so what is 8? To what exponent do we raise 2 to in order to get to 8? Yeah. Okay, so again, use your calculator and check. There's absolutely no reason, okay, you don't need to guess on these. There's no reason to get these ones wrong. 2 to the power of 3 is the same as 8. What about 16? What is 16? 2 to the power of what? Yeah. Okay. And then don't forget the 16 had an x, so we have to keep the x there. Okay, guys, now we have the same base. The same base. What happens when we multiply the same base? What do we do to the exponents? We add them. Okay? So it's going to be 3 plus 4x. You can't add those anymore. Do not tell me 7. Okay, because the 4 has an x attached to it. So when you're collecting like terms, okay, you can only do 3 plus 4x. You can't push them together anymore. Okay, because one is just a number and one has a variable. Yes?
You have to show that top step because you just went 8 times 16, 128. Oh, 2 to the 7.
Okay.
You skip that step.
Okay, so here's the thing, guys. The 16 has an exponent. You cannot multiply the 8 and the 16 because the 16 is already taken with the exponent. If you were to multiply it by 8, then you would get the wrong answer. You have to treat these separately. Okay? You have to treat them as separately. Okay, it's sort of like this. It's sort of like collecting like terms. You can't just say 7x because that's not. Okay, the answer is 3 plus 4x. So because this one has an exponent of x, the 8 would have an exponent of 1. Okay, so they're not the same exponent. You can't just multiply them together. Okay, so that's a really good thing. Okay, so
Separate if they don't have the same.
yeah, yeah.
What if they have different?
They have to have the same base in order to do anything with them. Okay, guys, how about this one? Okay, no worries if the numbers on the bottom of a fraction, we're going to do this, it's the same thing. Okay, we are looking for 512. You tell me what exponent, okay, 2 to the what will give me 512? Okay, Reese is fastest on the calculator. He told me it's 9. Okay, and it is. Okay, so guys, like, just put numbers in, right? I started a bit low. I started at 2 to the 5, and I was still like 32. So I was like, okay, maybe 2 to the 8. Nope, still too low, 2 to the 9. Okay, now don't forget, you can put it in brackets, so now you can see this is a power of a power. So what do I do with my exponents when I have a power of a power? You're going to multiply exactly. So this is going to be 1 over 2 to the 27x. Because 9 times 3 is 27. Yeah. Yeah. Okay, guys, what is an alternative answer if I didn't demand positive exponents? Okay, what if I wanted like base 2 and I wanted it up on top? Yeah, okay, and then what would you do to flip it? Like, what would you have to change? Yeah, you would do a negative exponent. Okay, so guys, this is also equivalent. This is the same as this. Okay, we flipped the base and we changed the exponent to a negative because that's what a negative exponent means. Yeah.
So you can, when you're adding your exponents,
yeah,
they have to have the same variable, right?
Yes.
But
well,
when you're multiplying, they don't.
When you're adding, like you're collecting like terms, you can still add them, but they don't simplify anymore.
Yeah.
But yeah, when you multiply, yeah, you're multiplying.
You can go through.
Yeah. Okay, next one here, guys. Okay, they want the base to be a 2 and a 3. Okay, so they're basically saying 16 to what exponent is 2, right? So connect the 16 with the 2, connect the 81 with the 3. Okay, and they better be the same exponent. Okay, so double check. So I heard 4. So if you do 2 to the 4, do you get 16? Okay, and if I do 3 to the 4, do I get 81? Okay, so that means that we've just done this. Okay, let me do it this way. Okay, 3 to the 4, 2 to the 4. Okay, this is the same thing as putting the same exponent on the outside so that it gets all of them. Okay, I'm just going to, where do I want it? Here. And the original question had this x plus 5 hanging on. So you still have to put the x plus 5. Okay, make sure you put brackets around it because it was separate, because you have to multiply these. If you just like put it beside, you might miss the fact that the 4 gets multiplied through and the 4 times the 5 is the 20. Okay, if you just like put it up beside, you might get 4x plus 5. And it's a multiply here. Yeah. Yeah.
Oh, so you write it with the bracket. Next, you also take brackets away and just write it on both top and
yeah,
bottom.
this is simplified. This is a little bit more elegant. This is the preferred. Okay, outside right, because otherwise it gets a little messy, right? When you've got that kind of exponent that's exactly the same on the top and the bottom.
Same deal, just
Yes, different formatting. All right. All right, guys, make plans after class. All right. So now we're ready. Okay, we just did changing the base and learning what to do with the exponents. So now we're ready to actually like solve for this x. Okay, so here are the key things that you want to do. Okay, guys, this is important.
Sorry.
Okay, so you're first of all, you're going to have this equation. As soon as you see that there's an equal sign, that means we're solving for x. So the first thing you want to do is your questions have to have the same base. They have to. Okay, so your first thing is to figure out what the base is and to change the one that is maybe not in that same base. So right now we have a base 5 and we have a base 25. Could we change the base 25 to a base 5? Yeah, let's do that. Okay, so write each side with the same base. So we're going to go 5, 4x plus 2 is equal to 5 squared times my x. Okay, so that's your first step. Make both of them to have the same base. Your second step.
Don't you gotta do 5 squared right?
It's the same thing. Okay.
The other way.
I just simplified. There you go. I'm okay if you want to do the extra steps. That's fine. Okay. So guys, here's the thing. Okay. Just like when we did common denominators with rationals, and once we got the common denominator, we said, thank you very much for doing your job. Okay. So once we have the same base, yeah. Okay, so now, because we have the same base, now the exponents are the things that are going to be equal to each other. So we're going to have 4x plus 2 is equal to 2x. Okay, this is easy. I like the sound of that. This is easy. Yes. Okay, now you just solve for x. Get all the x's on one side, everything else on the other. So you're going to go minus 2x, minus 2x, minus 2, minus 2. So we should have 2x is equal to negative 2. There. So if you got x is equal to negative 1, bravo. Okay, if you guys wanted to check, how could you check? Like that your answer was right. You could plug it in. Okay? Absolutely, you could plug it in. So you would do, on your calculator, you would do 5 to the exponent, and then you do 4 times negative 1 plus 2, all in your exponent, and you get an answer. And then the next line, you would do 25 to the exponent, negative 1. And you would look at those two answers, and if they're the same, then you did your question right. Okay? So equate the exponents on each side. That's what we did, and then solve for the variable. Okay, so let's do a couple. So the first few are, the bases are already the same for us. And then we're going to like increase the complexity and have to change the bases. Okay, so for this one, because we already have the same base, okay, we can equate the variables. So we have 2x plus 3 is equal to 7. Okay, if you got x is equal to 2, okay, you're good. Yes. Yeah. Okay, so I want you to do the B and C. Okay, B is the same thing as A. C, you're just going to change the 343 to a base 7. Okay, and then I'm just going to come around and see how we're doing. Okay, let's continue on. Okay, so we put up the solutions for the next two. Check your answers. So the first thing that you need to do, okay, is make sure that we have the same bases. Okay, and then you're solving for your x. Okay, so we have x is equal to 1 and x is equal to 5. All right. Now in B, it doesn't matter which side you put the x on. Okay, I put the x's on the left and they were negative, and then I just divided by the negative. Some people put them on the right and they were positive, but your answers are still going to come out exactly the same. Okay. So in the next one in D, okay, we're going to do that one up at the board, but I want to show you, okay, look at E. Whew, guys, E has a square root in it. We haven't talked a lot about square roots. Okay, this one we might want to. Okay, guys. Maybe you're both being distracted. Okay, you guys are distracting me. Okay, on page, okay, guys, I want you to go to your list of exponent laws. We're going to add one because we haven't talked about it yet. Okay, the law that I'm interested in is fractions. Okay, what does what does an exponent as a fraction actually mean? Okay, you guys did learn this in grade 10, but it's been a little while. Okay, this means, okay guys, when it's a fraction, it means that we have to take, it turns into a radical, okay, or a square root. So whatever number is on the denominator, that number becomes the index of my radical side, and then the number on top stays on top. Okay, so this is one, okay, that we haven't talked about that should be on the list. So that means that, let's say I had this. Let's say I had the cubed root of x. What would that be in exponential form? X to what exponent? Okay, if the denominator became the index, then that means that the index becomes the denominator. Yeah. Okay, so there's a connection between square roots, or what we call radicals, okay, and exponents as a fraction. So if we go back to your notes, this example here has a square root of 3. Okay, guys, look for Q's in the question. We want everything to be a base 3. So this one is already base 3, so we keep it as it is. The 27, we have to change to a base 3. 3 to the power of what gives me 27? 3. Okay, so we're going to do 3 to the power of 3. That's our 27. And then square root of 3 is 3 to what exponent?
Hang on.
Yeah. Yeah. Yes.
Well, maybe it is. I want to figure it out.
Okay, the square root becomes a fraction as an exponent. Okay, so some of you are going, how did that happen? Okay, we just did this here in our notes. We said a fraction, okay, becomes a square root. Okay, whatever the number is on the bottom, that's our index. Remember invisible math? Do I have radicals on that one? Right here. Every radical, okay, if it doesn't have a little number, the invisible number is 2. It means it's a square root. Okay, so in this question that we have, it didn't have a little number. That's why I put the 2. So this has an invisible index of 2. That's why my exponent is 1 over 2. Okay, now that I have all the same bases, okay, well actually let's combine these. What happens when I have 2 the same base and I'm multiplying them? What do I do to my exponents? Add them. Add them. Okay, guys, how do I add 3 plus a half?
3.5.
No, we don't want decimals though. Keep it as a fraction. Okay, you can still do 3 plus 1/2. Okay, math fraction it. Okay, so, okay, 3 plus a half. So remember, 3 would become, if you're like doing common denominators, it becomes 6 over 2. That's what 3 is. So 6 over 2 plus 1 over 2, that's where 7 over 2 comes from. Okay, so 3x is equal to 3, 7 over 2. Okay, we have the same base. So our exponents. Okay, so keep it in fraction form. Okay, so this was, so if you need to make a note to yourself, this was 3 plus 1/2. Okay, that's where the 7 over 2 came from. We're adding the exponent. Okay, so f is the same. We're going to change everything to a base 2, so that square root of 2, tell me what exponent it's going to have. Square root of 2 is going to be 2 to the 1/2. Yep. Okay, so why don't we, I want to see how you guys are doing. Bring your notes package up to the board, and we're going to do D, F, G, H, and I on the board.
Let's go, board work.
Yeah.